Okay, today we are looking at nuclear fission, the reaction. So, in a previous video, I spoke about nuclear fusion. Nuclear fission is a different way of releasing energy. And this time, rather than things fusing together, we actually take atoms and split them apart. And it turns out that splitting large atoms apart also releases energy. So, what kind of large atoms are we talking about? And how exactly does this process work? Okay, take a uranium-235 atom. And we need something to start this reaction. So grab yourself a slow-moving neutron and basically fire the neutron towards the uranium-235. That uranium-235 absorbs that neutron and therefore becomes uranium-236. Remember, these numbers refer to the mass numbers of my atoms. And since my uranium has gained an extra nucleon, it now has that larger mass number. And my uranium-236 is unstable. It splits up into two smaller daughter nuclei. Yep, they are called daughter nuclei, and the uranium-236 was the parent nucleus. I'm not sure why they've chosen that gender. It might be that it was just an arbitrary choice, but if anyone knows the reason, please do let me know. And my uranium doesn't just split up into these two new daughter nuclei. In the process, it also releases a few neutrons and, the important bit, energy in the form of gamma radiation. So a typical reaction might look a little something like this, with my uranium and my neutron turning into krypton, baryon, and releasing a few neutrons as well. Now, here's the genius bit. Since splitting that uranium nucleus up released a few neutrons, I can then use those neutrons released to go on and hit into other uranium-235 atoms. Now all of those uranium-235 atoms will react, will split into daughter nuclei, energy and neutrons, and then those neutrons will go onto other uranium-235 atoms. Those will undergo fission, more neutrons released, so on and so forth. And this is what we call a chain reaction. And call me delusional, but I like to think it was actually this process that inspired that classic Diana Ross anthem. So, as you can imagine, actually, there's a bit of a problem with this process, which is as those neutrons are released and go on to hit more uranium-235 and more and more and more, the amount of uranium atoms that are undergoing fission increases exponentially. So I get loads and loads of energy being released at the same time. That kind of uncontrolled reaction is something you'll definitely have heard of before, and it's called a bomb. So we need to be able to control that reaction so that it releases energy at a rate that we can use safely. In the next video, have a little look at the actual reactor itself and how we control that reaction. Okay, hope you found that helpful. Make sure to download the notes below. If you like the video, give us a like and subscribe. Thanks for watching.